About dictionary in Python. Now let's get started. So dictionary is a collection which is unindexed and mutable. Now, why do we say that dictionary is unindexed? Because we do not use numbers as index positions here. We only make use of keys as index. That's why we say dictionary is unindexed and mutable. The meaning of mutable here is it can be changed at any point of the time. And dictionary is a map which is a key value pair. So basically, dictionary stores the element or item in the form of key value pair that is separated by a colon. And in Python, dictionaries are written using the curly brackets or flower braces. Now let's have a look at the syntax of dictionary. So here we have dict1 equals and then opening flower bracket 1 colon John. So if you see 1 here is the key and then followed by colon, and then John is its associated value. And if you see here, the key and value pairs are separated by colon. Now let's see what conditional statements are. So conditional statements are part of flow control statements or decision-making statements or control flow statements. So flow control statements determine the order in which statements are executed at runtime. We have three types of flow control statements. First one is conditional statements. So in conditional statements, we have if block, else block, and elif block. If block is basically going to check the condition. And if the condition evaluates to true, then it is going to execute the body of if block. Then we have else block, which will not have any condition to check. Whenever the if block is failing, then the control goes to the else block. And then we have elif block. So whenever we have multiple conditions to check, we go for elif block. So we can only have one if, multiple elif, and then else block in conditional statements. Next, we have looping statements. So in order to move over or iterate over elements in any sequence, we make use of for loop and also while loop in order to check some Boolean condition, and it evaluates to true until the condition remains true. Then we have transfer statements that is basically going to transfer the control from one place to another place in the program. We have break, continue, and pass as keywords for transfer statements. Now, conditional statements execute until condition remains true, and the syntax of these flow control statements make use of colon and indentation. Now, let's see what are loops in Python. So Python has two primitive loop commands. One is for loop and the other is while loop. So objects in Python are iterable. The term iterable means to move over or iterate over any elements in the sequence. And for loop also makes use of colon and indentation. Basically, for loop is going to be used when we have any iterations to perform. And then while loop evaluates to true until condition remains true. So once the condition is evaluated to false, the while loop is automatically terminated. So now let's talk about for loop. So objects in Python are iterable. The term iterable means to iterate over every object or every element in the sequence. The sequence can be anything like string, list, tuple, sets, dictionary, and so on. We can use for loops to execute block of code for iteration, and a for loop is used for iterating over a sequence. Now let's have a look at the syntax of for loop. So we have a sequence variable, my underscore sequence equals, here I've taken an example of list. And this list is having 3 elements. It means this particular loop is going to run for 3 times. And then we have for keyword followed by iteration variable in the sequence variable. And then we are going to print this iteration variable. So you can take iteration variable as anything num, I, j, k, item, element, whatever you want. Now let's talk about while loop. So with while loop, we can execute set of instructions or statements as long as the condition is true. Once the condition is evaluated to false, it automatically terminates the while loop. Let's have a look at the syntax of while loop. We have while keyword followed by some Boolean condition. It means here we will check for a variable to be greater than or lesser than some number, or greater than or equal to some number, and so on. If this condition is true, then the control goes inside the while loop. While loop basically has three important steps: initialization, condition, and then incrementation or decrementation based on the condition. Now let's see what are functions of Python. So functions are nothing but group of statements that perform a specific task. A function is a block of code which only runs when it is called. If you're not calling the function is never executed. And then we can also pass data to the function in the form of parameters or arguments. And a function may or may not have the arguments, and function can return data as a result. Now let's see how we can define a function. Let's create a function. In Python, function is defined using a special keyword known as def. Def here stands for function definition. Now let's have a look at the syntax. We have def keyword followed by function name and then parenthesis colon. In this parenthesis, if we have any arguments or parameter to pass, we can pass those. As I already mentioned, a function may or may not have the arguments. So this function is not having any argument. And then we have the code or statement that is forming the function body. Now let's see what are Lambda functions. So a Lambda function is a small anonymous function. It can take any number of arguments, but can only have one single expression. Lambda has a specific syntax that we need to follow. Let's see the syntax of Lambda function. So here we have f equals lambda a colon a into a. So here f is nothing but the function object that accepts and stores the result of expression, or you can, in other words, say that it is a variable that is holding the output of the Lambda function. And then we have this Lambda keyword. So if you see here, we do not have a def keyword or a name to our function. That is why we say that Lambda is anonymous, meaning it is not having any name. So Lambda keyword, and then this a here is argument. So argument list will be followed by the Lambda. You can have as many number of arguments you want. And then we have this expression. And the argument list and expression is separated by colon. An important thing to remember here is that we can have any number of arguments, basically list of arguments, but only one single expression. So now let's hop to Python and check out the example of dictionaries, conditional statements, loops, and functions in Python. Now here I'm on the Python. So I'm going to right click on the project name, go to new Python file. And here, let's first create a file by name dictionary. Now let's see what dictionary is. Dictionary is a collection which is mutable and unindexed. And it's a key value pair. Now let's go and create a dictionary. So dictionary is created using a flower bracket. So if I say D, you need not write the dictionary variable name as DICT because DICT here is a built-in. So I'll just make use of D. D equals flower bracket. If I say something like 1 colon, let me take the same example, 1 colon John, comma 2 colon let's say Sam, and then 3:, let's say Bob. And then I'm going to print this dictionary D. Also check the type of it by writing print type of D. So if you see here, 1, 2, and 3 are the key of dictionary, and John, Sam, and Bob are their respective values. And all the key value pairs are separated by colon. And the elements here are separated by comma. So let's run and check the output. So I'm going to click on the second run, dictionary. And you see the output is dictionary, and the class here is text. So now we'll see how we can access the dictionary items. So here I'll say accessing dictionary items or elements. So as I already said that it is unindexed, meaning we cannot make use of numbers as index positions here. If I try doing something like print D of 0 and run, you see this gives me an error, key error, because we cannot make use of numbers in order to access the dictionary elements. Now, in order to access dictionary items or values, what you have to do is you have to here mention the name of the keys. So if I want to access this value, or let me say accessing dictionary values, here if I say 1, because 1 is my key name, and now when I go and run, you see I get the output as John. If I say print D of 3, I get the output as Sam. Now, if I want to change this dictionary, let's say I want to change value of this particular dictionary. So how do we do that? For example, I want to change the name Sam to, let's say, Steve. How do we do that? We first need to have print, or we'll first take D, that is name of dictionary, and then the key of Sam, that is 2, equals, and then assign the new value to it, Steve. And now when I go and print my D, now you see the output is 1: John, 2: Steve, and 3: Bob. So this is how you can change dictionary item. If I want to add one more item to dictionary, add an item to dictionary. So if you want to change the item, you need to keep the key same. If you want to add a new item, you have to take another key. So I'll take 4 this time, equals, let me assign a name, Tina, to it. And now when I print D, if you see 4: Tina has been added to the end of the dictionary. Similarly, if I want to access both keys and values together from my dictionary, so I can just go and say print D dot items. Items are collectively key and value pairs. So now when I run, you see the output is dict underscore items, 1 John, 2 Steve, 3 Bob, and 4 Tina. So this is about dictionaries. Now let's go and see what conditional statements are. So I'm going to create a new Python file here. Name this to be conditional statements. Hit enter. Now what conditional statements are? Conditional statements will evaluate until condition remains true. So the first conditional statement, I'll just list out the conditional statements here. We have if, we have else, and then we have elif. So the syntax of if is something like this. We'll have if keyword followed by the condition. So let's say I'm going to check if 1 is less than 2, and then print something like yes. So if this condition 1 less than 2 is true, then the control moves or goes inside my if block, and I get the output as yes. So let's run and check. So I'm going to quickly run conditional statements, and you see the output is yes. Now, what if I reverse the condition? If I say something like if 1 is greater than 2 and then print, if I say something like hi, so you see here I get a slight discoloration because the condition here is evaluating to false. So it means I should not see the output hi. So you see the only output we have is yes. Now, what if I make this a nested if and let me change this condition to something like 3 is greater than 2. Yeah. So now see what happens. If 1 less than 2 is true, then it should print yes. If 3 greater than 2 is true, then it should print high. So now when I go and run, you see the output is yes and high because both the conditions are satisfied. This is outer if and this is inner if. Now what happens if I change this condition? So you see 3 less than 2 is false. That's why I get only the output as yes. Now I'll change this condition back to 3 greater than 2, but here I'll reverse my condition. So here I'm checking if 1 is greater than 2, it should print yes. But if you see at the inner if, I'm checking 3 greater than 2. Though this condition is true, but you can see here there is a slight discoloration indicating an error, right? So in this case, you see I don't get any output. The reason is because this is a nested if. It means whenever we have nested if, the outer if should be true, then only you can execute the inner if. If the condition at outer if is evaluating to false, then you cannot run the condition at inner if, even if it is true. So this was about if. Now what happens if I say if 1 is less than 2, print hello? Or let me say if block, and then I'll have else. Else will never have a condition to check. Whenever the condition at if is failing, then the control moves to else block. So now here I'll say this is else block. And now when I go and run, you see the output I get is if block because the condition 1 less than 2 is true. What if I reverse this condition? When I say 1 greater than 2, if condition is failing, that's why I don't get the output as if block. And the control goes to else block. Else will not have any condition to check. So whatever is inside the else body would get printed. So now when I go and run, you see, I get the output as else block. Now, if I say something like if 2 is greater than 3, okay, let me say if block again. Now, I want to check one more condition here. Let's say elif. And this time I'll say 3 equals 3. And then print here I'll say elif block. And then else. Print here I'll say else block. So the condition at elif is evaluating to true. That's why I get the output as elif block. All right. But what happens if both if and elif are evaluated to true? So if you notice here, if I say 2 less than 3, okay, and if I run, now you see I get the output as if block. Though the condition at elif is true, 3 equals 3, this is not evaluating because either of the condition would get evaluated. It means if both if and elif are true, then only the output of if will be printed. Only if the condition at if is failing and the condition at elif is true, then only you can see the elif block getting evaluated or printed onto the console. So this is when you have multiple conditions to check. elif not only checks a single condition, you can check many conditions using elif. For example, if I say name equals John, and here I'll check if name equals something like Sam, and then it should print hi Sam as the output. And then I have elif that checks for name equals Bob. If this is true, then it should say hi Bob. similarly, if I have elif, name equals John, print hi John, and then another elif that says name equals Tina, print hi Tina. And then lastly, we'll have an else block that says something like print what is your name. So now try answering this question. So here I've assigned the value John in a variable name, and I'm checking if the value is John, then it should print hi John. So let's go and check what the output it gives. So you see the output it gives is what is your name. So now whenever you look at the code, you would directly say that it'll print this line number 27, hi John. But why is it printing this else block and giving us the output, what is your name? The reason is here I'm using capital J. The variable value starts with capital J, and I'm here checking for the small j. So if I want the output to be hi John, I can just go and change this to caps J. And now when I go and run, you see the output is hi John. So because the variables are case sensitive in Python, it was giving us this else block output. So this was about conditional statements. We have also seen the multiple LF ladder. Now we'll go and see what for loop is. So I'm going to create a file by name for underscore loop. And let's say for loop. So for loop is mainly used for iteration. The syntax of for loop is we will first have some list created over here. Any sequence, I'm going to take a list. Let's say my list equals. These are my list items. Now I want to iterate over this list. That is, I want to print the numbers 1 to 5. It's not a compulsion that these numbers should be sequential. You can take any numbers like 1, 2, 10, 12, 20, 100, anything you want. And then you have to write for, followed by the iteration variable. You can take anything as iteration variable here. Let me take I. For I in my list colon. See, as soon as I write a colon and hit enter, it automatically takes the indentation. And now, if I print I and run, sorry, I need to select the file to run. So now you see the output is 1, 2, 3, 4, 5. So this loop is running for 5 times. Now, same thing if I say something like for j in my list colon print hi. So now let's see what happens. Here, if you see the iteration variable is j, but instead of printing j, I'm actually printing hi. So this is actually valid. This is not invalid. So what will happen here is this j, that is the iteration variable, will be pointing to these elements of the list. In the first iteration, j will be pointing to 1. Instead of printing j, I'm printing hi. In the second iteration, j will be pointing to 2. Instead of printing j, I'm printing hi. And this goes on until the last element of the sequence, right? So what should happen now? J will be pointing to these elements, and instead of j, I'm every time printing hi. It means hi should be printed for 5 times because our list is having 5 elements. So now when I go and run, you see the output is hi, hi, and hi 5 times. So this is how you make iteration over the list. If I want to, let's say, sum up the elements of this list, I can do that as well. Let's say sum up list elements or items. So how do we do that? I'll take a variable, let's say sum equals 0 first. Or let me take list sum equals 0. And then I can run the loop, let's say for num in my list. Here I can say list underscore sum. equals list underscore sum plus num. And then inside the for loop, if I'm printing the value of list sum, it should give me the output of each and every iteration. So for example, the list sum value is 0 for the first time, equals 0 plus the value of num. First value of num is 1. So 0 plus 1 becomes 1, right? Equals 1 plus second value is 2. So this becomes 3. This is only for the understanding purpose. 3 plus 3. So if you see, the num value is ranging from 1 to 6. It will range from 1 to 6, 1 to 5 because the last element is 5, right? So this will be 6 equals 6 plus 4. And then you have 10 equals 10 plus 5. So the last value you get is 15. So we are basically trying to get the same value. So now if I go and run, you see, you get all the iterations 1, 3, 6, 10, 15, whatever I have written. If you want only the output, that is the final output 15, then you need not write your print statement inside the for loop. You just come out of the for loop, and here you can write print list underscore sum. So now when I run, you should see it only gives me the output 15. If you have both the print statements, then you should see the 15 element printed twice. One from the inner print statement and one from the outer print statement. Similarly, I can also go and check if my list is having any even numbers or so. So here I'll say check for even numbers in my list. All right, so what I'll do is I'll say for I in my list. All right, so in order to get the even numbers or print the even numbers from the list, we need to write a condition for even numbers. That is, we need to check for divisibility by 2. So here I'll say if I mod 2 equals 0. This condition is used to check if a number is even or no. All right. So now here I'll say something like I comma is even. So I is basically my number, or it is an iteration variable that is going to be pointing to the numbers, right? So I'll copy this list again here for reference. Or I'll say my list equals 1, 2, 3, 4, 5. Okay. So now see what happens if I run. You see it gives me output 2 is even and 4 is even. So because the first element is 1 and the condition here is not satisfying, it's not printing 1. For 3 also the condition is not satisfying. That is why it is not printing. Now you can iterate over strings. So I'll take a string, let's say my underscore string. This is a variable equals, I can say something like hello world is my string. So I'll write the for loop to be, let's say, for letter in my underscore string colon print. Here I will print the letter. So let's run and check what happens. You see the output is hello world. And now what if I want this hello world to be printed on one single horizontal line? So how do I do that? Here I can make use of n command, and let's say n is equal to space. So what will happen after each and every iteration? It will be ended with a space. So now when I go and run, you see the output is hello world. All right. Similarly, if I say something like for letter in Python colon, if I say something like print hello. So what should happen here? First, we will check if this is valid or no. So here, if you notice, this hello world string is saved in a variable or stored in a variable called my underscore string. And here, I'm not storing Python in any other variable. I'm directly iterating over the string. So that is also possible. You don't have to write an extra variable over here. And every time this letter is pointing to elements of the string Python, let's say a letter will be pointing to P in the first iteration. Instead of printing P, it should print hello. In the next iteration, instead of printing Y, it should print hello. Instead of in the next iteration again, instead of P, it should print hello. So hello will be printed 6 times. Let's go and see the output. Now you see the output is hello has been printed 6 times. And another thing, if you notice here is the first hello is overlapped with the previous output. So it's combined or joined with the previous output. The reason is one of the use of end statement is to end with whatever is specified over here, and the other is to join two print statements. So whenever you use end in your print statement, the very next line, you can just go and write an empty print statement. So this will create the space between the two outputs. So now when I go and run, you should see the hello should be shifted to next line. This hello that was initially here or earlier here is now has been shifted to hello because of this empty print statement. Now let's see how to iterate over tuples. So I'll say something like T1 equals 1, 2, 3 for I in T1. I'll say print I. So this should just give me 1, 2, and 3 as the output. All right. We have a concept known as tuple unpacking. For that, what we'll do is we will create a list of tuples. So list of 1, 2, 3, 4. So this 1, 2, 3, 4 are the pair of tuples. And here I'll say 5, 6 and 7, 8. So if you notice here, each and every tuple is holding pair of elements. We have only 2 elements inside the tuples. I'll print this list and also check the type of list, as well as I want to know the length of list. That is how many elements this list is holding. So I'll go and do print len of lst. Len should return the total number of elements inside the list. So now when I go and run, you see the output here is class list and the total number of elements are 4 and not 8. That is to be remembered. This pair of tuple is one single element of our list. Now let's do the iteration. If I say for I in lst colon print I and run, so you see we get the output as pair of tuples 1, 2, 3, 4, 5, 6, 7, 8. Now what I want is I want to unpack these tuples. By unpacking, I means I have to remove these elements out of the tuple brackets. So how do we do that? Because each of the tuples are having a pair of elements. So what I'll do is I'll make use of 2 variables in order to iterate. So I'll say for T1, T2 in LST. And then here I'll say print T1 and in the next line print T2. So now when I go and run, you see the output is 1, 2, 3, 4, 5, 6, 7, 8 in different lines, and we do not have the pair of tuples. Now what happens if I say T2 and T1? So here T1 will be pointing to the first element. So this will become your T1. 1 is T1, 2 is T2, 3 is T1, 4 is T2, 5 is T1, 6 is T2, 7 is T1, and 8 is T2. So now when I first print T2 and then print T1, so it will be 2, 1, 4, 3, 6, 5, and 8, 7 as the output. It's not going to be 8, 7, 6, 5, 4, 3, 2, 1. So this is how we unpack the tuple elements. Now, let's say I have to iterate over the set. So I'll say iterate over set. I'll create a set, let's say s equals. Set is also written in flower bracket. So I say 1, 2, 3 are my set elements. I'll say for I in S. And then when I say print I, let's run and check what output it gives. So you see the output is 1, 2, and 3. Also, we can iterate over the dictionary. So here I'll create a dictionary. Iterate over dictionary. So here I'll create a dictionary. Let's say D1 equals, let's say the dictionary is brand colon BMW, model colon, something like, this is to be like this, model colon 3 series. And then year colon something like 2018. So I'll say print D1 and run. You see, this is the dictionary. I have to iterate over this. So I'll say for I in D1. And now when I print I, this will only give me my keys, that is brand, model, and year. If I also want the values, so here I'll say print the dictionary name of I. So this will give me values. So the output will become brand BMW, model 3 series, and year 2018. You can also make use of keys and values built-in function, or you can also make use of items function to iterate over both keys and values at a time. Now let's say I want to display numbers from 1 to 20 to 50. So what I'll do here is I'll make use of for I in. Now, whenever we say we have to print numbers from specific number to specific number, it means from 20 to 50 here is a range, right? So I'll make use of range function and say the start of range is 20 and the end of range is 50. And then I can say print I. So range will include the first item and it will exclude the last item or end of the range. So it will print from 20 to 49. It will not print 50, isn't it? So now what if I take the same and this time I give a step value of 2. So this will print alternate numbers. It means it will print 20, 22, 24, 26, 28, so on up to 48. The reason why it is printing alternate number is 2 here is the step value. It's not a compulsion that step value will always give you even numbers. It mainly depends on the start of the range. If your range starts with odd number, then it will print odd numbers. If your range starts with even number, then it will print even numbers. So you see the output is from 20 to 48. If you want to see on one single line, you can just go and write and equal space here. And now you see the output is 20 to 48. So now let's say we have to print multiplication table of a given multiplication table of a number. Multiplication table of a number. So now let's see how we can do that. So what I'll do is I'll first try to get the number from the user using the input function. So here I'll say x equals input. Because I'm talking about number, I need to first typecast this input function into int, because input function by default accepts only string values. Now here I'll say something like enter a number. And then here I'll write my for loop. I'll say for I in range, because I want to print the multiplication table, it means I want to print from 1 to 10. So I'll take the range to be 1 to 11. And then here I'll say print I into X, isn't it? Because I will be ranging from 1 to 10. X is the number that we are taking from the user. So also I have to write an empty print statement here in order for the outputs to separate. So now when I go and run and say 2, you see the output I get is 2, 4, 6, that is 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8, so on up to 2 tens are 20. If I actually want to print that in the form of a table, so I can say for I in range, only the print statement changes here. So in print statement, what I'll do is I'll say print X, caps X, whatever I'm writing inside the quotation would get printed to the console. So I also want to have an equals, and then either I can write I into X or X into I. So I'll write I into X. So this is my number. This is the into symbol that is written in the form of string. Then we have I that is ranging from 1 to 11. That is, it will print 1 to 10. Equals again will be printed to the console, and I into X will be the computational value. So now when I run and say 2, you see this is how our multiplication table looks like. Right. So this was about for loops. Now we'll go and see how we can make use of while loops. I'm going to create a new Python file and name this to be while loops. So while loop evaluates until condition remains true. So what does it mean? It means that until and unless the condition is false, then the while loop will be continuously running. For example, if I say while x less than 5 colon, here is the while keyword and followed by Boolean condition, and then I want to print the value of x. Let's see what happens if I go and run this. So I'll go to run, click on my run and click on while loop. So you see I get an error here saying name error, name x is not defined. Obviously, because x is a variable to which we have not defined the value, we have not initialized the value. That's why it gives me an error. So the very first step of in while loop is initialization of variable. So here I'll say x equals 0. So this is the first important step that is known as initialization. And then here we have condition to be checked. Now let's run and check what happens. So if I run, you see what's happening. It's giving me 0, 0, 0, 0 continuously. So I'll just simply quickly stop it. Otherwise, it might crash my PyCharm as well. So now another important step here is that I need to increment the value. Incrementation or decrementation depends on the condition. So here I want to increment the value of x by 1. That is as good as telling x equals x plus 1. And this step is also known as incrementation. And now when I run, you see the output is from 0 to 4 because I'm checking for x less than 5. So it means it will start from 0 and it will end by 4 because I'm checking for x less than 5. If I also want to print 5, then here I need to give x less than or equals 5. Now, similarly, if I want to print numbers from 1 to 20 using while loop. So here we first need to see what is the start in order to initialize the value. So I'll say I equals 1. Okay, then while x is less than 21. I could either say x less than 21 or x less than or equals 20. That should also work. And then here I'll say print sorry, this is I and not X, I, and then print I and also increment the value of I plus equals 1. So now when I go and run, you see the output is, it's printing numbers from 1 to 20. Now, similarly, if I want to get the output in this way, let's say 5, 4, 3, 2, 1. I want to print the series of numbers. It's decreasing, it's in decreasing order. So how do we do that? We first need to initialize the value of variable. Let's say X equals 5. Okay, because I want the number to be, first number to be printed as 5. And then I can check for the condition. Let's say while X is greater. This time I have to check for the greater because the value I'm using is greater here, right? Because I'm actually trying to print in decreasing order. So here I'll say if X is greater than 0 because the last number here is 1. Or you can say X greater than or equal to 1 equals. And then here I'll say print the value of X. This time we have to decrement the value of X and not increment because the condition we are checking is reverse. So here I'll say X minus equals 1. All right. So let me quickly run and check if this gives me the output 5, 4, 3, 2, 1. So you see the output here is 5, 4, 3, 2, 1. Again, if I want in one single horizontal line, I can simply go and say end equals space. And now when I run, you see the output is 5, 4, 3, 2, 1. So we don't have a lot of things in while loop except for these three important steps: initialization, condition, and incrementation. So whatever code you write, you're going to write the same. But if you ever come across while true, if you try giving your Boolean condition true, so it means inside the while loop, you have to compulsorily make use of break statement in order to voluntarily break your while loop. Right. So now let's go and see what are functions in Python. So I'll create a file by name functions. And here I'll say something like functions are group of statements that execute block of code, or you can even say particular instruction or specific instruction. Now functions can be built in or user defined. Now what are built-in function? I'll write the example of built-in function. We have this print function that is built in, that is going to print to the user console, or it's going to print whatever we write inside the print statement. And then we have input. Input basically allows the user input. Now, when we have any computation to perform, we mainly go for user-defined functions, like we have any processing to do or calculations to perform, then we go for user-defined functions. Now, how do we write the user-defined function? We need to define the function using the def keyword. So for example, let's say I have to create a function. So I'll first start with the def keyword. Anything that starts with def in Python is a function. But if you make use of the same functions in object-oriented programming, you call those functions as methods in object-oriented programming. But if you're not using object-oriented programming concepts, then anything that starts with def is a function. It's a user-defined function. For example, if I say def greet followed by parenthesis colon. So def is the function definition followed by name of the function. Greet here is name of function followed by parenthesis. Parenthesis here is given because if we want, you can add arguments or parameters to the function. But a function may or may not have the arguments or parameters. So I'm not passing any arguments to it. Simply, what I want is I want to print some greeting here. Let's say print hi and print hello. So now if I run and check, let's see what happens. If I run, you see the output is nothing. I don't see any output over here. Okay, the reason why we don't see the output here is that we are only defining the function and we are not actually calling it. So here I can go and call the function greet. This is calling or invoking the function. Calling or invoking the function. And now when I run, you see the output is hi and hello. So again, I can go and say greet and run. You see the output is once again hi and hello. So the main use or advantage of function is that it is mainly used for reusability. That is, you can write your function code once and call it as many number of times in the same file or in different file. Now let's say I have to write a function to add two numbers. So here we'll make use of function arguments. Let's say def add is name of the function that takes two arguments, a and b. Because here we want to add two numbers, we need to pass two arguments over here. And here I'll say c equals a plus b inside the function body. And I can say print c. I can directly write print a plus b also. And then call the add function and pass the values to the arguments. Let's say 10 and 5. So a will become your 10 and b will become your 5. So now when I go and run, you see the output is 15. Similarly, if I want to call this function passing different values, let's say 3 and 4, and now when I run, you see I get the same output again, that is 7. Now let's say I have to write a function to find average of two numbers. So how do I do that? Def, let's say avg is name of the function that takes two arguments, let's say a and b. Here, instead of taking c equals a plus b by 2, I'll directly take a plus b whole divided by 2. And then I'll call the function avg and pass the value, let's say 10 and 20. Because this is a print statement, we also need to write the bracket of print statement. And now when I run, you see the output is 15. I can also go and say something like average of two numbers is colon, comma, and run. You see the output is average of two numbers is 15. I can also write the string inside my print statement. Now, what if I say that functions can execute or return back some result? All right. So let's say I have to write a function to return sum of two numbers. So what I can do here is I can say def sum and let's say a comma b. And here I will say something like c equals a plus b and then return c. So if you notice here, I'm not making use of the print statement. Instead, I'm making use of the return keyword here. So now when I go and say sum and pass the value like 2 and 3, expected output is 5. Let's run and check. So you see, it doesn't give me any output, right? The reason here is that inside our sum function, we do not have any print function to display the output, right? Now, how do I display the output? I can call the sum function inside my print function like this. And now when I go and run, you see the output is 5. Or I can do one more thing here. I can take another variable and call the function this way, let's say 3 and 5. And then I can go and print the variable result. And now when I run, you see the output is 8. Similarly, if I want to write a function to return average of two numbers, so here I'll say def average. Let's say average is name of the function that takes a and b as the argument. And here I'll directly say return a plus b whole divided by 2. And then I can go and use print statement to call the average function and pass the value 10 and 20. So now it should give me 15.0 as the output. Now, another important thing is that functions can return multiple values. Now, how do we say that functions can return multiple values? So let's create a function. Let's say calc is the function that takes a and b as the argument. Basically, this calc function will perform 4 operations, arithmetic operations. Let's say x equals a plus b. That is addition, y equals a minus b, that is subtraction, z equals a into b, and then u equals a divided by b. Now we have to return this. Now, important thing to remember here is that we have to return all these variables x, y, z, u in one single line, followed by the return statement. You don't have to write your return 4 times like return x, return y, return z, and return u. You shouldn't have to do that. It'll give you an error. Now, so what we will do is we'll directly call our calc function and pass the values like 10 and 5. And now let's see what output it gives. So now when I run, you see the output is a tuple that is holding the addition, subtraction, multiplication, and division of these values, right? Now, what if I want to unpack these tuple elements? I can directly make use of for loop this way. For I in calc of 10, 5, and then colon print I. And now when I run, you see the values have been unpacked out of the tuple. Or I can also go and make use of result. Result equals calc of 10, 5. And then I can say for I in result, colon print I. It should also give me the unpacked output. All right. So this is how functions can return multiple values. Now let's go and see what actually function arguments are. So I'm going to create a new Python file here, name this to be function underscore arguments. So let me write an example here. Let's say def my func is name of the function that takes x as an argument, inside which I'm having a variable called x. Let's say x is 5. And I want to print the value of x. I'll say x is colon comma x. And then here I'll call my function, like let's say my func, and pass value 6 to it. So normally what happens is the execution starts from line number 6. That is when we call the function, the function execution begins. So this function will take x as an argument because x we have as an argument here. And inside the function, we have a variable again by name x. So what will happen? Let's go and check. So now when I run, you see the output, it gives us x is 5 and not x is 6. The reason is because the argument name and the variable name is same here. Now what I'll do is here I'll write a user defined function to update some sequence, let's say list. So what I'll do is I'll first go and check the ID of my list. So I'll say print ID of list. I want to check the address of my list variable, and I also want to modify one of the element of my list. So here I'll say list of 1 equals 25. I don't know what elements my list is having right now, but I want to change one of them. I want to change the element at index position 1, and then I'll say print ID of LST. Okay, and then here I'll say print something like LST is colon comma LST. And then I'll call my update function. So here I'll say update. Before that, I could write list equals the elements, let's say 10, 20, and 30. And I can pass this list, or I can directly pass my list elements using the square brackets here. So now when I go and run, so you see the address is same before and after modification of the list, and the list elements I'm passing is 10, 20, and 30. But you see 20 has been changed to 25 because I have changed the element at index position 1. So this is index position 0, this is 1, this is 2. So that's why 20 has been changed to 25. So this is about function arguments. Now let's see what is scope of variables. So scope of variables is well defined in and out of the function. We have two types of variables. One is global variables and the other is local variable. This is global and the other is local. A variable that is defined outside the function and that can be accessed inside and outside the function is known as global variable. A variable which is defined inside the function and can only be accessed inside the function and not outside the function is known as local variable. For example, if I say x equals 1, 2, 3, here x equals 1, 2, 3 is my global variable. So here I'll write a comment saying that this is a global variable. And I'll create a function, let's say def display. And inside this, I'm going to create a local variable y that takes output 4, 5, 6. So let's say this is local variable. And then when I print the value of y, I get the output 4, 5, 6. Inside function, if I print x, I get the value 1, 2, 3. Outside the function, again, I want to print the value of x. And then call the display function. So if you notice here, the first global variable I have written x equals 1, 2, 3. I did not immediately print x after that. Instead, in between I have written in between x equals 1, 2, 3 and print x, I have written the function that is display function. So now what will happen? First, there are 3 print statements here. The first print statement it will print is line number 10 because it is outside the function. Then we are calling the function, right? So from line number 11, it goes to display. Inside display, we have print y, that is, it will print 4, 5, 6, and then it will print x. So now when I go and run, let me run the file. And now you see the output is 1, 2, 3, 4, 5, 6, and 1, 2, 3. Now, if I comment this, and if I write my print statement here, after calling the display function, so what will happen here is, first it will go and execute the print statements inside the display function. So it should print 4, 5, 6 first, 1, 2, 3, and then lastly, line number 12, 1, 2, 3. So it should be 4, 5, 6, 1, 2, 3, and 1, 2, 3. So here the sequence changes. Now, what if I go and say print Y? And let's run and check what happens. So you see, it gives me an error saying name Y is not defined. Obviously, because Y here is the local variable that cannot be accessed outside the function. That is why it gives me an error. Y can only be accessed inside the function because it is a local variable defined inside the function. Now, let's see how we can access global variable with same name. So here what I'll do is the global and local variable name I'll keep same. Now here we will use the global and local variable name same. So what I'll do is I'll say A equals, let's say 1, 1 is my global variable. So I'll say here it is a global variable. And then I'll write the display function, def display. And my local variable name also I'm going to take same. Let's say A equals 2, 2. This is local variable. And then print A. So now if I go and run my display, call or execute my display function, because I have print A inside my display function, it will only execute and give me the output as 22. So you see, I get the output 22. What if I again go and write A here? Okay. And again, if I run, this still gives me 22. So it means that because the local and global variable names are same here, I cannot access my global variable inside the function, but I can do it outside the function. So now when I say print A, this print A on line number 22 will again give me the output as 22 only. What I want is, I want the print A on line number 21 to be 11 and not 22. So for that, we have a special keyword known as globals. And inside the square bracket, we need to mention the name of the global, mention the name of the variable. So now when I run, you see the output is 11 from here, line number 22. 22 from line number 20, that is print A, and then print globals of A will give me output as 11. So here, accessing global variable inside the function using globals keyword. So now this was about scope of variables. Now let's go and see what are lambda functions. Now lambda are small anonymous functions which will not have any name and lambda functions take any number of arguments but single expression. So I'll also write down the syntax of lambda function. The syntax is lambda keyword followed by argument list. So org underscore list colon, then we have expression. So let's say I have, what I'll do is first I'll write a function that is normal function, a function definition to find the cube of a number. So I'll say def cube of n colon return n to the power of 3. And then here I'll say cube print cube of 3. All right. So let me run and check what output it gives. So I'll run Lambda functions. You see the output is 27. Now the same thing, the same function definition I want to write in the form of lambda. So how do? I first say lambda. And then followed by argument list. So if you see here argument list, we have only one single argument n colon, then we need to write the expression that is n to the power of 3. And all of this is to be assigned to some variable or lambda function object, let's say L equals. And then I can say print L of 3. And now when I run, you see the output is again 27. So if you see here, lambda functions are very easy to write when compared to normal function definitions. Let's say I have to write lambda to add 3 numbers. Now, how do I do that? Let's say f equals lambda. So when I say add 3 numbers, it means I have to take 3 arguments over here. So I'll say a, comma b, comma c, colon a plus b plus c. And then print f of here. I'll pass 3 values for a, b, c. So I'll say 1, 2, 3. And now when I run, you see the output is 6. Lambda to concatenate strings. Now let's see how we can concatenate strings using lambda. So here I'll say s equals lambda. Let me say comma b colon a plus b. And here I can pass strings like hello, comma world. And now if I go and run, you see the output is hello world. If you want to have a space, you can either have space here after hello or a space before world. Now you see the output is hello world. Now we will see what are lambda functions methods. Now the first lambda function method we have is filter. Okay. Filter filters out sequence elements based on some logic and conditions. Now let's see the syntax of filter. So the syntax of filter is filter will take 2 things. One is function, the other is iterable. By function, I mean here it's a lambda function. And iterable is the sequence variable that we are going to use. All right. Now, what kind of problems we can solve using this filter is, let's say we have to retrieve only even numbers from list of given numbers. So basically this list will have both even and odd numbers, out of which we will be only filtering out the even numbers. So let's say 1, 2, 3, we have 10, 12, 16, 5, 7, something like this. So now how do I retrieve this? First, I'll write down filter and the lambda function inside it. So lambda x colon condition for even number. Let's x mod 2 equals 0 and then LST. That is the iterable. All right. So this entire thing we need to assign it to some variable. Let's say that is result. Result equals filter off, and then I'll say print result. And now when I go and run, You see the output I get is filter object at some specific address. Now it means that the output has been generated, but it is not viewable or printable. The reason is I have to typecast this into list this way. So now when I do this and run, you see the output is all the even numbers 2, 10, 12, and 16. All right. Now, the next method we have is map. So map will or you can say it will maps the sequence elements based on some logic and condition. Again, we'll write the syntax of map. So it is map lambda function, or I can just say function, and then iterable. Now let's see where we can use map. So here I'll say in the given list of elements, double each of the list element. Let's say list is having elements like 1, 2, 3, 4, and 5. By doubling means I want to multiply each of these elements by 2. So how do I do that? Here I can say map and then lambda function, that is lambda keyword x:x into 2 and then lst. Again, I assign all of this to a variable called result. And then I can go and print the result. Let's see what happens. So now when I run, you see the output is, it creates a map object at this specific address. Again, in order to see the output, I just need to convert this into list this way. Typecast this into list, and now you see the output is 2, 4, 6, 8, 10. So it means all of these elements are, or you can say this expression has been applied to all of these elements, x into 2. So it is 2 into 1, or 2 into 2, 3 into 2, 4 into 2, and 5 into 2. This is what map does. Now the last method we have is reduce. So reduce will reduce the sequence elements to single value depending on some logic and conditions. So now, for example, let's say in the given list, sum up all the list elements. So let's say the list is LST equals 5, 10, 15, and 20. Also, let me here write down the syntax of reduce. Again, that would remain same. Here I would say reduce function and iterable. Again, say here result equals reduce. All right. So function is lambda function. Whenever we have to sum up the elements, we need to take two arguments and not one argument. So here I'll take x comma y colon x plus y, because there should be something to which we are adding something, and then pass LST here. So your x becomes 5, y becomes 10. 5 plus 10 becomes 15. X becomes 15, y becomes 15. Then 15 plus 15 becomes 30. That is, x becomes 30, y becomes 20, right? So in total, you get the output as 50. So now when I go and print the result, let's see what happens. Now when I run, you see it gives me an error saying name error, reduce is not defined. So reduce actually is a function that is present in a module called functools. So what you have to do is, first you have to import reduce using this particular keyword or particular import statement. So that should be from func tools import reduce. Okay, so if I uncomment this, you see I get the error on reduce has been gone. If you ever don't remember this import statement, there is one more way. What you have to do is, you have to just place your cursor over here, and if you click on this, you see you get an option here, or you can just press Alt Enter. You get this option and you can click on it. And if you go back to the beginning of your file, you see from functools import reduce has been imported automatically. So now when I go and run, you see the output is 50. So for reduce, we don't have to typecast or convert it into list, because however, the output is reduced to one single value. So this is about Lambda function.